Hello world, it's Siraj, and I've built a tool for teachers called EssayBrain that automatically grades essays and checks for plagiarism. So let me start off by showing you a demo of how this tool works, and then I'll explain to you in detail how I built it so you can take this code, it's totally open source, it's in the video description, and build an AI startup with it as a base repository. Use it to create some sort of profitable business that's impactful for other teachers. I'm here as the espresso for you, right? I'm here to give you that shot to start, to get going, to build something, right? I could easily take this code and run with it and build a business out of it, but it's better for me, it's more impactful for me to enable you to be the person to do this. So let me show you the demo. So the first thing I'm gonna do is I'm gonna sign in as a user, right? Siraj is my username. And once I've signed into EssayBrain, okay, so this is the dashboard. I can upload a bunch of essays here, or I could type in an essay. So if I wanted to, I could just upload, some text, some PDFs of some essays. I can upload multiple, so I can upload them in batches. But I can also just type in the essay here. So what would be an example of an essay? Let's ironically paste some text from OpenAI's blog on GPT-2, which is one of the technologies I use to build this. Let's paste it into here, okay? So once it's in here, I'll go ahead and I'll say validate. And so what validate is going to do, great, it worked. What validate is going to do is it's going to check how likely it was that this essay was generated by an AI. Because this is a new form of plagiarism, I guess. It's a new form of non-ownership where someone can just say, oh, I know the writing prompt, let me just generate an essay. I don't have to do any of the work, right? So this is a new type of plagiarism, not necessarily taking a source from another place on the web or some other author, but taking a source from an AI as well. So this does both. It checks online for different sources and it checks if this text was generated by an AI. That's the first thing that it does. It validates an essay. And so what you're seeing here is all of the text that's green is text that is very likely that was not generated. All the text that is red is text that was very likely that it was generated. So because there's a lot of green text, this text was very likely not generated. Now, if I want to be able to have multiple batches, if I want to be able to upload multiple essays, then I'm going to have to pay a price. And so the price is $200 a month, $200 US a month for unlimited essays. But if you want, you could do this one at a time. So that was an example of Stripe integration. Of course, you could use whatever payment processor you want. Now that's one step. Now what you've seen here as well is it automatically grading the essay as well. So it gives each essay a validity score to say how likely this essay was to have either been real or fake. So 95 is good. The closer to 100, the more likely it's real. And then what the grade score is again, on a scale of 0 to 100, what's the quality of this essay? Now, how did we judge the quality? That's a really good question, right? How are we actually judging the quality? So I found this essay data set on Kaggle. It's a couple years old, but it's a really good labeled data set because it's got many hundreds of essays. And for each of them, a professional human rater, so it's human labeled, they rated each of those essays based on a writing prompt on a scale of 1 to 10. And then based on those, we can say, okay, so this is what a human considers to be a good essay based on this writing prompt. And because there's a lot of writing prompts, that gives it an ability to generalize. So we need to have a lot of writing prompts, right? We need humans labeling it, and we need there to be a lot of different varieties of topics because we want this to be as generalized a model as possible. So I'd use this data set to train a model with, and then I incorporated that into this web app. So it's got a couple of different things happening in here, okay? And what you're seeing here as well are, different charts of how likely it was, and I'll explain those later on in the video. So how did I build this thing? I used a couple of tools. The first one is, of course, Python to code this, and the popular Python web development framework Flask. So Python and its framework Flask. I also used an API, a plagiarism API called CopyLeaks that's got SDKs in a bunch of different languages, which is great. I also used the GPT-2 unsupervised language model that OpenAI recently released, and we'll go into detail on that one. That's the really interesting part. I used Tensorflow.js to serve the model, so I split up the training process and the serving process. So I trained it in Python, and then I served it with JavaScript, and you'll see the pros and cons of that and why I did that. I also use Stripe for payments, and then I use D3.js to show a bunch of, those little colored visualizations that we saw. And then I used Firebase to store the data, right, for user sign-in and authentication in the database. So you might be thinking, well, I understand Python, but maybe not GPT-2, and maybe this one or that. I've got dependency videos for you to watch, prerequisite videos, 3. The first one is this video I recently released called OpenAI Text Generator, where I go into the details of how that model works. The second is an intro to Tensorflow.js video, where I explain all the different intricacies of Tensorflow.js, and then an optional video or set of videos for you to watch before this one is my entire Watch Me Build playlist here on YouTube, where I've been building applications for real-world use cases in medicine and finance and now education. Okay, so the steps in this tutorial are going to be for us to first find GPT-2 hopefully as a Flask web framework, right? So it's already wrapped. This trained model is already wrapped in a Flask web framework that we can run on our local machine. And once we find that, then we can add features to it as a fastest method to prototype, methodology. And then we're going to analyze its structure, we're going to redesign it, we're going to add in login sign-up functionality, we're going to integrate CopyLeaks, we're going to integrate Tensorflow.js, we're going to train our model in Python in the cloud, download it, and then load it up via Tensorflow.js to serve to users. We're going to display the scores, validity, and then calculate those. How are they going to actually be calculated, as well as the grade, and then we'll add in the payment functionality last, and then we'll upload it to the web. But to start off, let's talk a bit about the bigger picture here before we get to building the code. So there are a lot of applications of AI in education. In fact, think about how automation technology is taking over or replacing humans in a lot of different professions, right? No profession is safe. AI is going to be able to do everything, law, medicine, all those safe professions as well. It is truly, truly, truly a powerful technology it's the new electricity for a bunch of different industries. What does that mean for education? What that means is the need for learning, the need for education, for self-directed learning, for tools for teachers, for tools for students will only increase over time because it's going to be necessary for people to reskill themselves for an economy that's changing so fast. So this is a good trend for entrepreneurs like yourself, right? Or aspiring developers in general who want to make impactful solutions for society, because we know that the need for education will only increase as automation technology improves. So we can build tools for that. So what are the possibilities here? Well, personalized learning is a huge one, right? Not everybody learns in the same way. Not everybody learns at the same pace. So if we can build tools that personalize learning for each individual student, then we'll have done a service for them. Now, how do we do that? How do we personalize things? AI, right? Recommendation engines. Netflix has a personalized feed for you. Google does, Facebook does, all these services do. There's also virtual tutors, right? AI assistants, natural language processing. These are text generation chatbots that are trained on some data set of knowledge, whether that be in science or in whatever field. Assessing open-ended questions, so Q&A systems, question answering systems. Sentiment analysis to see for teachers, how students are feeling about a particular topic, right? There's so much data on the web. NLP is a tool for students to learn, right? What if a student wants to learn about a specific topic? Let's say quantum field theory, but there's a lot of jargon. If there was an AI that could take all that knowledge and parse it down into an easily understandable paragraph, that would be supremely useful, right? So there's so many different possibilities here. And there's so many goals as well. So if we can think about the actual objectives, like what are we trying to do here? We can actually make something impactful. So this is a good thought exercise. Let me try to increase retention. Let me try to increase outcomes like, graduation, etc. Lower the costs. All these things are things that teachers try to do anyway. So we want to fit into that mold and provide them with an engineering solution that will do that. And like I said, the use of AI in classrooms, both on and offline, will only increase across the world in the coming years. So this is a good field to disrupt and provide real solutions to people with. Now, on to language models. So formal languages like programming languages like Python can be specified as an API, right? They're pretty static. But human languages are not. They are actually an ongoing process, new slang, lit, cool AF, all these like slang terms. It's a dynamic process. So it's a lot harder to model a language, right? And so what we mean by language modeling, it's the task of assigning a probability to sentences and words in a given language, right? So given some set of words, like I want to go to the mall to buy a what? What is the probability that this blank word is going to be a certain word? Well, we can look at the context of what this person has said before to try to predict the likelihood of what this word is going to be. I love NLP and like dogs. So this is just an example of how we encode these words as vectors, which are groups of numbers. Now, language models are supremely useful, right? So every time you're, in Google, you're typing in a word, it's using a language model internally to predict what that next likely word is going to be. Also in, texting on whatever, phone that you use. So these are just probabilities. These are probabilities, and there are different ways of computing these probabilities, right? Is it the probability given only the previous word? Is it the probability given the previous 3 words, maybe the entire document, right? So there are different ways of structuring these language models. And fortunately for us, last year, 2018, was the year of language models. Google released BERT, bidirectional encoder representations of transformers. That's what it stands for. OpenAI released GPT, generalized pre-training of transformers. Fast.ai released Elmo. So all of these language models were trained on massive data sets of text, lots of text data sets. And so why this is useful to you specifically is because what you and I can do is we can take these language models that are open source, freely available on the web, and they were trained on all this text data. And once they were trained on all that text data, we can then use them as a starting point to perform transfer learning. And when I say transfer learning, what I mean is there's so many different NLP tasks out there. Question answering, sentiment analysis, text generation, text classification. And when we use a pre-trained model, we don't have to train it ourselves. So that's a good thing, right? It saves us time and it makes it easier. So there was a similar moment like this in computer vision with ImageNet. So this was in like 2012 when ImageNet performed state-of-the-art in classification. And then anyone who wanted to perform classification could just build off of ImageNet. They didn't have to train on hundreds of thousands of images of dogs to then create a new dog classifier. So we've got our ImageNet moment now for NLP. And this just happened. So there's a lot of possibility, right? This technology exists. The scientific discovery was made. Now it's time for the engineering solutions, right? As this researcher says, a new era of NLP has just begun a few days ago with the release of the transformer model. So by the way, the transformer is the model that all these language models are using. It's using what's called a transformer, right? And so the TLDR on that is AI researchers were holding recurrent network's hand, but now it's like the transformer is here. So the transformer is replacing recurrent networks for all sorts of sequence prediction and language modeling tasks. And this is what it looks like, which is a collection of matrix operations. These boxes represent matrix operations, and these arrows represent the ordering from which the initial input data will start off with, and then all the operations that are applied to it until we get an output. Now, what does it do? It learns the what? It learns the mapping between the input and output, right? We know this by now. The normal transformer has both an encoder and a decoder, and the updated version only uses an encoder. But the idea is that when we want to make a language model, we need to know 2 things. We first need to know what does a word mean, so the semantic meaning, which we can gain from the embedding of the word, the vector representation of the word, and then what is its position in the sentence. And so using both of those 2 things, we can make a prediction of the next word, both the context and the semantic meaning of the word. And we can represent both of these things as vectors, both of these concepts. So we're going to take an input and create both an input sentence matrix and a positional encoding matrix. And that's what flows through the model to give us our output. So let's do a little quick demo, shall we? We can basically code GPT-2 here and train it in 5 lines of Python, which is pretty amazing. This guy I found on GitHub had this repository that he built GPT-2 in PyTorch with, which is super cool. He rebuilt it for PyTorch, which is amazing. And then once we have that, we can so we're going to clone it directly into this notebook. Then we're going to cd into that location. And then once we're there, we're going to perform a curl command that takes the output and it says, okay, so take that model, which is already, it's pre-trained, so it's already saved, and he saved it in AWS. And once we've got that, model, we're going to run it right here directly in the browser, and then we're going to test it ourselves. So last thing I'm going to do is I'm going to install the requirements. So this is a pre-trained model, and the last line of code is Python main.py, and then whatever the text is going to be. So let's say, what's the text going to be? When I was just a baby boy, my mama used to tell me. This is some Eminem song. It will take this prompt and it will generate an entire, essay from that prompt. Okay, so it generated it. So it says, when I was just a baby boy, my mama used to tell me to go to my mother's house. Do you remember what happened? He stopped, looked at me. He said in a deep voice, I don't remember. The baby was just a little girl, but she was crying. Whoa, okay, this is pretty real, right? This is pretty cool. So let's keep going here. So GPT-2 is really good at being able to generate text by predicting the probability of a certain word in a sentence. Now, we can use that technology to also see if some given text was generated by an AI. How? We create a probability likelihood of what the next word is going to be, and then check the actual next word. And if it matches, hey, it was likely generated. If not, okay, then it was a human. So in that way, it can become a tool to detect what's real versus fake. So let's see if this exists somewhere on GitHub, and then we'll use that as our base repository. How about GPT-2 classify text? Detecting fake text. Hello. Okay. So we found something. This looks pretty cool. Let's use this as our base repository. This person has created a version of GPT-2 that can basically detect if some text was real or fake. So we're going to use that as our base repository. So what do we have to do? We have to do a pip install. Okay, so what's the first step here? Let's install this thing and run it locally. So I just downloaded it, and now we'll do pip install, and we'll see if that works. Pip install our requirements.txt. Great. Python 3 server.py. Okay, got it. Okay, let's see what it looks like. Wow, okay, cool. So this works. So let's see, cats playing in the garden. Great, it works. So this is a Flask app, right? Let's see what it is. Let's actually analyze what's inside of here. I already did this before. I'm just doing this to show you guys my process here. Okay, so it looks like a Flask app. So if we go into backend, all right, let's analyze this code base. Let's see how it's working here. So what's happening is inside of the backend file, we have the API. So let's actually start at server. So in server.py, it's using Flask, and it's got a couple of logic routes. So these are the main ones, like analyze some text and then send the response. Get all those available models that we have. And then we have the non-logic routes, like what's the main page, right? Where's the data at? And this one's actually pretty simple. And then a bunch of command line arguments. Great, that seems pretty simple. Okay, so if we go into the distribution folder and then we type in this, okay, so it changed. So great. So now we know how to modify this. Okay, so great. Now what else is in here? We've got the index, right? We've got some CSS, some JS, right? That's not much. So here's the interesting part, the API. So this is the really interesting part. What it's doing is it's pulling these pre-trained models as a Python package. So this is a pip package. And it's got GPT-2, it's got BERT, it's got a bunch of them, and then it implements this interface called Abstract Language Checker. Inside of the interface, that's where the methods are. Using these pre-trained models that it's pulling from this package, it's checking the probability of all these values. Now, this is just the interface, so the logic isn't there. Now it's going to implement that interface for GPT-2 in particular, the small version. So then to check the probabilities of each word, it will say, okay, let's process the input, let's encode it, turn it into a tensor, forward it through the model, and construct the target. This is like post-processing of like making sure the tensors are in the right shape, and then returning the payload. And in this case, it would be the probabilities for those next words. And so it's got another one for BERT. And in fact, if we have our own language model, we can implement our own interface and then add that to this mix. But already it's got several of them, and then we can use them to for this text. So what we're going to do is we're going to reskin this, and then we're going to add our own features to this, right? So let's start doing that. So let's use my whiteboard. I got a new whiteboard to show you some of these ideas visually. Okay, so what do we want this app to look like? Let's kind of write out visually what we imagine this app to look like, right? So to start off, fastest method to prototype, we'll start off with a login screen, or we could just say like index as well. And then we've got the dashboard. And this is where that main functionality, both the grading and the validation, will go. And so in the login screen, what do we want it to look like? Well, we want there to be a toolbar for login and sign up. So this is for login and for sign up. And we can have some kind of modal pop-up here, and we can actually reuse the modal view for both of these. And then we'll have Firebase here as well. So Firebase is going to be integrated on the back end. So these are the tools we'll use for this first view. So Firebase is the first tool. And then we'll have some kind of asset here to show, like, hey, welcome to our app, blah, blah, blah. And then we'll have another login button here, maybe some text as well. So that's it. Well, Firebase is the only, real technology we're adding to the mix here. Now, once we've signed up, or we've logged in, then we get to the dashboard. Now this is what we started off with, that page, right? We're going to modify this and add a new page, and that's where the user starts off. So we already have that validation functionality. So that's GPT-2. So we know that that's going to be there. So a user will be able to type in their essay, but we also want to add some other functionalities of dropping in a CSV file. So, or multiple, not CSV file, a doc file, or any sort of document. So we'll add a CSV functionality, right? So CSV, or not, I keep saying CSV because I'm so used to data science. We'll add upload functionality, multiple upload functionality, upload multiple. And so, users will be able to drag and drop, they'll be able to type text, and then we'll show those results here. So D3 is going to be there. And in fact, it's luckily for us already integrated there. And then lastly, we're going to have our actual grading AI as well. So not just checking for plagiarism, but grading as well. And so for that, we're going to want to use Tensorflow.js to serve the user. So Tensorflow.js. Okay, so those are the tools that we use. We'll use 4 of those, and then we use Firebase here. Now, what else do we need to do? We need Stripe as well. So we'll add Stripe as a functionality here that we'll add. And what else? Stripe, GPT-2, upload, D3, TensorFlow, Firebase. Yeah, that's it for the first prototype. So let's start building. Okay, so first let's add a landing page. So I'll go into the distribution, which is the one we want to go to, and then we'll add a landing page. So we'll say new file, and we'll call it landing.html. Okay, and then we'll add a route for that. So hello is that first page, and then we'll add a route for that in server.py. So what we'll do is we'll say client landing.html, and then back in the app itself, we can then see it. There we go, hello. Okay, so now that that's there, we'll add some logic to that index page. So specifically, we'll add that toolbar that we talked about, as well as those assets. Okay, so what I've done is I've added a bunch of HTML to that landing page, and now it looks like this. Okay, so let me explain to you what I've added here, because I didn't want to use too much time just for like HTML, which is pretty simple. I changed the background color to this color. I went ahead and I used brand mark to generate a logo. So remember, brand mark is a great way to easily and for free generate a logo on any thing you want. And I generated one here, and then I matched the color of that logo. So this is the logo that I generated right here, EssayBrain. And then I matched the color of that logo to the background. And then I added a nav bar, just like this, which is a version of this nav bar is a type of, it's like Bootstrap, which is a package for front end, very popular package for front end. And then inside of that, I added these 2 elements, both a sign in and a sign up button, and they're using this UI primary button. And then I added this asset right here, AIDL for schools, some text, and then a login button, and then some CSS as well, right? So, and then this is a modal pop-up. So on click, whenever a user clicks sign in or whatever, it's going to show this other, just like that, and it's going to use that original logo as this, curve, as a circular logo. Username, password, and then you log in just like that. Email, username, password, on click, da da da. So now we can add Firebase to this. right? So whenever a user clicks anywhere, inside of the app, they've typed in their username and password, we want to input some Firebase code. So if we go to Firebase and we see like, how do we do this? This is happening in JavaScript. We can say, okay, so when you do that, do this, da, 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 da. But a better way to do this is to do this in Python. So actually, in server.py, we can create a new non-logic route, or we can create a logic route called def Firebase. And so what this is going to do is it's going to log in with Firebase. So Firebase Python is what we're looking for, Flask. Firebase Python Flask, give me some GitHub. Okay, so now we're in here. Let's go to sample code. All right, so import Flask, import da-da-da, great. Let me import that up here. Yep, and then we have to do an install, pip install. Okay, makes sense. And then I'm going to have my account, production sign in, and then so here's some good logic code. And then, actually all this is good, right? Because we have sign out, sign in, load user, it's all right here. So just copy and paste that, and we're good to go. All right. And so then back in the index.html, what we can do is we can create a form. So how does it go? It's like call Flask function from JavaScript. I'm a professional Stack Overflow searcher, by the way. And then once we have that, we'll say, right, so this is the name of the route. And once we have that name of the route, we'll say perform a post action to that route from HTML. So right, so that would look like this. And then we'll say, that route's name was, what do we call that? We call it Firebase Login. We're going to call it Firebase Login. And then we have our button, which is the login button. It's going to the value is going to be the username and password, which I've concatenated as one string. And it will pass that in, all right? So that's for Firebase. Now onto the next page. So now we want to modify that original page we saw. So we'll just easily take out all that text and we'll replace it, we'll reskin it. That's easy. But then what's like the real, hard stuff that we have to do is the question, right? So what we have to do is we have to add in that CopyLeaks API, right? So let's start with that CopyLeaks API. So copyleaks.com. So it's a plagiarism checker. It's a tool. So if we go to tools, we go to API for developers. And so what this is doing is it's checking for similarity on the web. It's not checking for generated text. It's checking for similarity. So we're adding on to this. We're using both, checking for similarity and seeing if something was generated or not. So we don't need all of this stuff. What we need is some Python, right? We need some good old Python, good old GitHub. I love it when people have GitHub repositories. It's so amazing. I love GitHub. I love coding so much. Okay, so usage. Okay, so you've got your API key, you import it, you start a process, create, it could either create by URL, it could create by text, that's the one we want. So it's going to take some piece of text that we input, and then it's going to scan it and return it as a response. So we just copy and paste that and create a new Flask route, a logic route. So back in server.py, we'll create our own logic route, and we'll call this logic route def CopyLeaks. And inside of CopyLeaks, we'll paste all of this in. So we know we need to import, we know we need to import these three, and then we have our authentication. We'll add in our API keys later. So now it's there, authentication, and then at start a process and get all that stuff. And then we'll add that to our, this to our create by URL. No, not create by URL, create by text. Create by text is what we want. So that means the parameter is going to be the essay. That's the parameter. And so we'll just type that parameter in instead of that, and that's going to be our process. And then process is completed. This will be our logging functionality, great, and then our results. Get those results, and then return the results. Easy. So easy, right? Okay. All right, so that's a good CopyLeaks, and then we'll call it back from JavaScript. Okay, so that's for CopyLeaks. Now, what else do we want to add to this? we want to add some other things to this. So we have CopyLeaks, we have the built-in GPT-2 model. We need to see what else we want to have. So Tensorflow.js. So Tensorflow.js has no right to be this easy to install. It's so easy to install. It's incredibly simple. So if we go to the Tensorflow.js examples page, we'll see very simple ways of using its API. So what we want to do is do this like super simply. So we'll say tf JS MNIST example. Right, so we want something even simpler than that. Tensorflow.js MobileNet example. Okay, so we just load that in, and then it sets up MobileNet by creating an asynchronous Java function that takes an image, in this case, performs transfer learning on it using this downloaded model MobileNet, and then makes a prediction with it. So if we just copy and paste that in, we'll get it. So here's what that looks like. So what we did was we created a script, right? So this is pulling Tensorflow.js from the web. And then we create a button, so the grading button, for example, right? So that what we saw in that demo that I showed earlier. And then we will create an image just for the sake of, making sure this works. So then we create this on-click function. So whenever a user clicks on the grading button, it's going to asynchronously load up that MobileNet model and then classify that image that we got from that div and then display the result in the console. So this is just an example to see if we could integrate Tensorflow.js into our file. And if we can, that's a good thing. So let's check it out. So we'll open up the console and we'll inspect what's happening here. So whenever we validate an essay, it's got all of those words. So we know that it's as an array, all those words. But for grading, the test here is loading MobileNet. It successfully loaded it. And then using a very small image, it was able to classify it. So this is happening in the browser. Okay, this is just, obviously we have nothing to do with image classification. This was just to see if we could integrate Tensorflow.js into this repository, and then we'll switch the model to our pre-trained model for our specific task, and then we're going to add the payments later, right? So now that we've integrated TensorFlow, we can add in our own model, right? The model that's trained to grade papers. So how does that look? So using this data set, so this happened a few years ago, this $100,000 challenge. So there must be a lot of repositories on GitHub that talk about how to use this. So it's called AES, Automatic Essay Grading. So if I just search, AES Kaggle, the chances are I'm going to find a lot of repositories, which is great. Okay, so I found a good amount. Auto essay grading, So one of them, and I found this beforehand, that's really good, is this TensorFlow example right here. That's called AES Grading. So this person built this feed-forward neural network with 4 layers, and what this did was it was trained on that AES data set, and it learned the mapping between the essays and the grades. And the result for this was, and we can see because it's an IPython notebook, or Jupyter notebook, it got a score of 0.9369, which is a fantastic result, very high accuracy. So what we can do is we can take this model and then we can run it in the cloud as a collab. We would save it and then load it in Tensorflow.js. So how would we do that? Well, luckily for us, Tensorflow has these great docs right here where we save it as an H5 file, so model.save, and then we can load it as an H5 file as well. But the thing is, Tensorflow.js, the JS TensorFlow, it's not save keras model Tensorflow.js. The JS TensorFlow needs a little bit of tuning to get it into Tensorflow.js. Now, this works for keras models. It also works for general TensorFlow models. It's got this, we have this Tensorflow.js converter here where we can give it the path to our saved model. And what it's going to do is it's going to export it directly to the tf.js layers format. And then we can load that model as well, which is perfect for us. Load it into Tensorflow.js by using this function right here, load layers model. And so it's going to be a JSON file. So we're going to have this instead, right? So we'll just comment this out. This is going to be the new model. And so I'll call it net, constant net await load model, and then we're going to call it, eventually we're going to save it as model.js in this repository. So say model.json. And so when it comes to training this thing, I trained several. I trained one in scikit-learn that I found, and I trained one in Tensorflow.js. And let me just quickly show you the scikit-learn one right here. So this one is the one that I used for scikit-learn as well. And so this person he did some EDA where he's like, all right, here are the essays. Let me do some data pre-processing, add some statistical features like, the standard deviation, the mean, just to add to the accuracy of the later model, standard data science stuff. And then he tried out a bunch of different models, linear regression, lasso regression, elastic net, and he found that random forests gave the best score. And then the idea is then to use grid search to find out the optimal hyperparameter combination. And once we do that, we can save that model and then convert it to Tensorflow.js because it's saved as a pickle file. Then we convert a pickle file to an H5 file, and then an H5 file to a JSON file, and we use Onyx to do that. ONNX, it's called ONNX, the library for converting models in one library to another library, converting pre-trained models in one library to another, which is super cool. It's called Onyx. So we can do that, or we can just do it with, directly with TensorFlow, and then we'll load it up. And so when it comes to displaying text on the page, right, whenever we validate an essay, it's going to do two things. One, it's going to use GPT-2 to create a score, right? A scalar value, a single value. And then it's going to use the plagiarism API to create another score. And then we'll find the average of those two scores. So score 1 plus score 2 divided by 2 equals our final validity score, which you see here. Then we're going to create a grading score. And the way to do that is to use the model that we just saw right here. And so that's also going to output a scalar value. And that scalar value is our essay score. And then, it's a float value, but we convert it to an integer and then display it as HTML to the user. And once we have that, we now have a score for both validity and the grade. Now, we also want to add this, very crucially, this payment functionality that is easily done with Stripe. Now, the great thing about building so many projects, not so many, but a good number of projects in this space, is a lot of your code starts to become reusable. You can start to reuse a lot of different pieces for things that you've built before, which is super useful. So, for example, I've used Stripe now so many times that I can just pull it from my own code, and then I can use it for whatever project I need. So I'll just search Stripe in this repository. There's my Stripe code right here, API key, sign up form, boom, right there. So I just type that in, and then that goes into the sign up form. And then it's super, it's just a little snippet of code, and then the nice little beautiful modal pop-up shows up. We can pay. They take care of all that authentication, the banking details, the card details. The key here is that we have created this technology, right? We didn't create it, but we implemented the engineering solution. Somebody else made the scientific discovery, but we are now serving it to people as an engineering solution. And the way to make this into a sustainable business where you can pay yourself, you can hire people to improve the product, you can grow it. The way to create that business is to create a paywall around this service, this very valuable service you've created, that people then pay you for. And then, ideally you have a subscription model. You can have a one-time payment if you'd like, whatever. There's a lot of different ways I'll let you worry about that. I'll take care of the engineering solution for you. Right, so that's an example of how to do this. After integrating Stripe, there are a bunch of things we can do to improve the app. We can create a continuous training pipeline, right? So remember the idea that we want to create a continuous training pipeline. This CSV upload, by the way, is so cool. It's called dropzone.js. Super cool. Dropzone.js, you just drag and drop some files. It's like super, super simple to install. It's like a few lines of code. And then it inputs this nice little beautiful box right here. So, right, we can add a continuous training pipeline where, new essays are uploaded, and then our model trains on those newly uploaded essays and the score that it gives those essays. So it gets better over time. And then the teachers can give some feedback as well, like, was this good or not? What's your feedback? And we can use that feedback as labels to our training data set. And the way we would do that is to implement TensorFlow serving, that's right, or Cafe2 if we're going to use PyTorch as a production grade serving pipeline. We can obviously have better UI design, and then we can have more Flasky routing. This was kind of like, jumbling these JavaScripts and HTML and CSS all together. We can separate those more cleanly in this paradigm. If it was React, then we would want to put it all together as a component. And then we would want JavaScript-based training as well. So notice how I coded it in Python. I trained the model in Python and I served it with JavaScript, but ideally all of that happens in the same language. And so, that's something we can do to improve, all right? So this code is open source. Use it as you'd like. Make a business out of it. Do whatever you need to do. Help people with it. Make money, help people, right? Those two things, those are the same thing nowadays, right? So I hope you found this useful, and please subscribe for more programming videos. For now, I've got to take a 24-hour break. So thanks for watching.